Welcome back, and thank you for rejoining us. For those of you just tuning in, this is the SpaceX Hyperloop pod competition where student teams from all over the world have come here to this weekend to compete to get the fastest time through our Hyperloop test track here just at SpaceX headquarters in Hawthorne, California. A quick recap of events. We had 3 teams that have made it to the 10th and final stage, which is a test run through this Hyperloop test track while it's pulling vacuum. Now, there are other milestones that they must have completed, and there are many other teams here this week that have been here for days doing all those vacuum tests, functional checkouts, communications, and navigation system checkouts. But 3 have made it thus far. Now, of those 3 teams that have made it to the final milestone, 2 have gone already. We had MIT run through the track this morning, achieving a speed of around 80 kilometers per hour. We then had Delft follow, reaching a speed of about 90 kilometers. We then had Bar from Germany follow, reaching a speed of around 90 kilometers per hour. We now turn to the 3rd and final team who was qualified for this 10th and last stage. The Delft team from Netherlands is in the tube right now. It has made it to the SpaceX pusher, and we are currently depressurizing the entire track for them to perform their 3rd run through. Now, we have a video that overviews the entire Hyperloop process, what we do it for, how it works, and so we're going to show that video to you as an introduction now.
Hi, I'm Director of Advanced Projects at SpaceX. Hyperloop is a point-to-point transportation system over ground that's meant to allow people to travel at extremely high speeds, up to 700 miles an hour. The idea originated from Elon back in 2013, when he noticed that the increase in speeds over ground hadn't really increased by any significant amount in a very, very long time. He also noticed that he himself was sitting in traffic a lot, and there has to be a solution. So he created the concept of a Hyperloop in order to give the world kind of a solution that could solve these 2 problems. And so we thought a great way for kind of the world to innovate would be to throw a student competition where we built a test track, a Hyperloop test track, and then invited student teams from around the world to build the best possible pod to go in that test track. And we left the competition very, very broad, so you could come with any really design that we can, as long as it was safe, you could do it. And so we conceived of that idea, and then in 2015, we launched the competition. We really didn't know what kind of reception we were going to get, but within a week we had 1,700 entries, which was astonishing. From there, we gave a few assignments, and eventually we narrowed it down to 120 universities. They all came to Texas A&M for Design Weekend in January 2016, where we had a great design competition. This week we have 27 teams representing 6 different countries. There's also a high school team here. And so the amazing response, not only from America, but from the entire world, is astonishing. We have had teams fly out from Japan, from Australia, from Germany, from the Netherlands, all for this competition, which we really appreciate.
Hi, I'm Flo Lee. I'm the senior engineer at SpaceX. So I've been working on the competition for over the last year, and specifically I've been working on the tube construction, and also been advising a lot of the teams. So this is actually the first functioning Hyperloop track. So it's really exciting. We think it's probably around a half scale for what you would use commercially. This is a 6-foot outer diameter. The tube is 4,150 feet long. We started with all the concrete foundation, and then once all the cradles were in place, we brought all the pipe in. The pipe came in 50-foot sections, and we welded it all together, and that happened in a span of over 2 weeks. And then we started working on the interior of the track, laying concrete, and then the interior aluminum subtrack after that.
So one of the main purposes of this competition was not to kind of constrain the students. The whole point was to innovate. So if you gave somebody at this point in society a train track and said build a train, most of the trains are probably going to look the same. So what we did is we created a Hyperloop test track that could accommodate almost any type of levitation. And so the 3 ones that kind of came out of that were air, meaning like an air bearing, like an air hockey table. That's what Elon originally proposed back in 2013. So this track allows for that. It also has a certain type of sub-track, we call it, which allows for magnetic levitation. So the majority of the teams actually have pursued magnetic levitation. And finally, there's a concrete outer side, which allows for wheeled teams. If you want to build essentially an electric car in a vacuum, you have the option to do that. You can make a great argument for any of the 3 being the best. And so it's really each team come up with their own idea. And so when you look at the pods, none of them look even close to alike, which is fantastic. The team from Japan's pod, you can literally fit in your hands. I'm sure it probably weighs 30 or 40 pounds. The team from Lehigh has a pod that I believe weighs over 3,000 pounds. So, and the range is enormous. I believe the Japanese pod is maybe a foot long, and the Lehigh pod is 21 feet long.
So because this is such a large chamber and takes a lot of power and a lot of resources for us to pump it down, we want to make sure before we put the pods in here that nothing is going to happen to them under a vacuum. So we have a smaller vacuum chamber. It's basically a 25-foot section of this tube where we pump the pod down to vacuum, and they have to do full functional checks and verify that everything is operating properly under vacuum. And if they pass that gate, then that's one of the things that they have to pass to get into the main tube. The other gate they have to pass is called the external subtrack, and that is basically an outdoor version of the track that's inside the tube. And on that track, they need to prove to us that they can, one, fit, so they have to align with the rail and fit on the track. They also have to show that they can brake, so they need to prove low-speed braking to us. Braking is very important. They also can show us general navigation, or they can also kind of prove out some of their levitation at low speed. We actually have a pusher at low speed to get them up to speed there, because some teams need to be at, say, maybe 15 miles an hour to actually levitate. So we've been able to show that on the subtrack first before getting them in here. If a team passes all of the gates to get in the actual tube, we're going to bring them out here on the loading dock. They're going to have to mate inside the tube, so basically we'll roll them inside the tube. After that, our pusher comes in behind. They need to verify that they have proper communication. Once all that is completed, we will close the door, and then we pump down the tube. Different teams want to go to different pressure levels, but if we go down to like a fairly low level, it'll probably take about 30 minutes. At that point, we will accelerate them with our pusher, and then they will be in the acceleration phase. After our pusher stops, they're in a coast phase, and ideally they'd coast all the way down, and then they'd hit a certain level where they hit their brakes and ride right up until the end. And if they can do that at the fastest speed, then they win.
The fastest team wins. So as long as everything is safe, which we ensure, whoever gets through that tube the fastest is going to be declared the winner. Just seeing the different designs has been amazing. If you walk around, it's 27 completely different designs, which is amazing. I'm super excited to see the first team get through this, because this is very non-trivial for the student teams. I mean, the tube behind you is a static tube; it doesn't really move. There's some thermal expansion, but it's not actively moving. These pods have a lot to do. They have to levitate, they have to have lateral control, they have to brake, they have to navigate. There's a lot of action, and they haven't had much time to build it. So if a school is successfully able to get through this final, I call it test 102, which is the Hyperloop launch, that would be spectacular.
The teams are extremely excited about Hyperloop. The ideas that they've come up with, all the things they want to try out for technology have been really impressive to me. Like, there's many teams that aren't necessarily just optimizing to win. They're here to try out new technology and things that they think will actually make this become reality. I think that's been really, really cool to see.